Hi, welcome to my talk as part of the Things Virtual Conference. My name's Paul, and I'm going to be talking to you today about mass deployment of LoRaWAN devices, such as sensors. So before I start, I'm just going to introduce myself to you a bit better. So my name's Paul Hayes, and my company, Alliot Technologies, distributes IoT hardware, and we solely concentrate on LoRaWAN technologies, and we distribute all manner of different LoRaWAN sensors, gateways, software services. But the reason I bring this up is because we also do lots of additional services as well. One of those is mass deployment and provisioning of LoRaWAN sensors. Prior to working with Alliot, so my other business was distributing voice over IP hardware, and in that market, for about over 15 years, we were handling the provisioning of voice over IP devices, and the company still does. And we worked with many of the VoIP hardware manufacturers and software providers to develop methods of doing provisioning securely and automatically. So I've got quite an extensive background in this, and I've been doing it for quite a few years in different technologies. So I just wanted to share with you today my experiences of what the current situation is in the world of LoRaWAN. So before I go any further, what do I actually mean by mass deployment? What is it? Well, what I really mean is provisioning of sensors and LoRaWAN devices. And when I say provisioning of LoRaWAN devices and sensors, that really means putting API UIs and app keys onto those devices. Because as I'm sure everyone here knows, to get any of these devices to work and to talk to a LoRaWAN network, you need to have an API UI and an app key on each of the devices, which matches whatever is on the server side. And getting lots of those keys onto lots of devices is a problem that needs to be solved. And why do we need to care about it? Well, if you're really wanting to scale your IoT business, then you've somehow got to be able to manage lots of these things. You've got to be able to do this in mass. And to move from the sort of proof of concept stage into doing thousands of devices all over the world potentially, you've got to be able to de-skill the process. You've got to be able to get API UIs and app keys onto your devices without it involving a laborious manual task. And as the slide says, LoRaWAN's it's really made the transition now from a proof of concept technology to full large scale deployments. It's been around for quite a few years now. It's a well established technology. Mass deployment isn't really something we kind of need to think about for the future. It's going on now. We need to be doing it now. We need to be thinking about how to make it work properly now. And yeah, you've got to get those pesky keys onto thousands of devices. It's not easy to do it in large scale. So when we come to think about how it actually works, well, there isn't really a how it actually works. There's lots of different answers to that question. At the moment, there's no standardized mechanism for actually doing this. There's nothing in the LoRaWAN spec about how to actually initially get your API UI and your app key onto your sensors. So various manufacturers of devices have left to decide how to do it themselves, and they've come up with lots of different mechanisms for doing this. And in my experience, there's kind of 4 or so different methods that have become common and are being commonly used. I'm sure more will appear over time as well, and I'll actually talk a little bit about what I think the future holds right at the end of this talk. Some of these methods I'm going to show you today I think are good, some of them not so good. I don't think it's fair to say that any of them are wrong. They all achieve the end goal of getting the device up and running, but I think some of them have got various drawbacks that we'll talk a little bit about today. So right into it then. So the first method of getting API UIs and app keys onto sensors, really basic, and I'm calling it fixed. And what I mean by that is where a sensor manufacturer produces a device, a sensor, whatever it might be, and at the time of manufacture, they then burn some firmware onto it to make it do something. That's the actual software that runs on the device itself. And in this case, they also then hard code the API UI and the app key into the firmware, or perhaps it's a separate little software upload to the device. And that's it. Then those are fixed. So you've got an API UI and an app key on that sensor, and they can never be changed. And they just burn it into the software on there, hopefully on a secure element inside the hardware, so that they can't be easily extracted. The biggest one of the biggest drawbacks to this is then how to actually distribute those keys to the customers. So if you're buying hundreds or thousands of these sensors, potentially not even directly from the hardware manufacturer either, how do you actually get those API UIs and app keys so that you can load them into your LoRaWAN network server? Well, the most common way that seems to happen these days is people emailing spreadsheets backwards and forwards, or CSV files. Clearly that can potentially be an issue, because who's seeing those keys and are they really secure? You need to be making sure that those keys aren't falling into the wrong hands. And the other thing is that what is the device manufacturer themselves? How are they actually doing this? Are they doing it in a secure way? Are they keeping text-based copies of your keys lying around in public documents potentially? Could they ever be compromised? And the other problem with fixed is you can never change it. So if there is ever a problem and those keys manage to get out into the world somehow, then you've got a problem there. And it is a problem as well. I really do believe that it's not accurate to say that this isn't a security issue. I've heard the argument sometimes where people say, well, if I've got temperature sensors, who cares if someone gets my keys and is able to decode the temperature that I'm sending back to a server every half an hour? Why is that a problem? Well, I don't really agree with that. I think it is a problem, because if someone's able to disrupt that communication, and if someone's able to decode that information and potentially then inject false information into it, at the very least, that's going to be a problem for your customer, because the system you've sold to them is no longer doing what it should do. And presumably you're charging them money to provide this as a service. So I really do think it is important that security is thought of from day one, even when things don't seem like they should matter. And the second method I'm going to talk about is what I call in-band provisioning. Now here, sensor manufacturers still load default API UI and app keys onto the devices, but rather than just being permanently fixed, they provide a mechanism whereby you can actually load your own API UI and app key onto that device by sending specially formatted downlinks to it. So it has to be able to talk to a network server to begin with using the default API UI and key that come supplied with it. But then it's your responsibility to change that API UI and app key to something else that you randomly generate. This has the obvious advantage over the fixed method in that at least you can change them, and you don't need to worry so much about what the manufacturer may or may not have done with those app keys before they send the device to you, because you can change them to whatever you want, and in fact you should change them to something else. You definitely should never stick with the default ones that come on the device if you have the choice to not do. I quite like this method because it's quite easy to do, and you can automate it as well. So I'm going to show you a bit of a demonstration in a minute of how to kind of manually do this through the Things network. But as you hopefully be able to work out, it's not that difficult to write a program that will use the Things network API to automate this process, which will allow it to work en masse and allow it to scale. The big drawback here is you're relying on people to actually bother to do this, and that's clearly an issue. If you look at the world of a lot of the things you hear about IoT, where people with CCTV cameras getting hacked and routers getting compromised and so on, it's pretty much always the case. It's where people have left the default passwords on those devices. People are inherently lazy. They won't bother to do this if it causes them grief. If they just see it as an extra bit of work they have to do that they can just get around by just leaving it to be default. So I think, as us being the people making the software, getting these products to market, it's our responsibility to make sure that this happens, to make sure that people are doing it, and we've got to make it as easy as possible for them. And so automation is the way to do that. It's got to be completely automated. Anyway, so what I'm going to show you now is I've got a little test device here that I'm going to use. So this is made by Netvox. And it's a really simple, you just press the button on it and it sends a LoRaWAN uplink to say that someone's pressed the button. But I'm just going to use this to show you a demonstration of actually changing the app UI and the app key on the device. So I'm just going to flip here to the web browser where I've just got my Things Network account here. So I've got the dev UI of this device already loaded on here, and then I've got the default app UI and the default app key that I know this device has come loaded with, and these were sent to me by Netvox when I bought the device. And in theory, I could just leave it like that and I could just let it run, but obviously, as I've just said, that's quite a dangerous thing to do. So what I'm going to do is, in this tab, I'm going to just leave the data stream of uplinks and downlinks so we can see what's actually happening. And I'm going to jump to the other tab here, and this is where I'm actually going to send the downlinks to the device manually through the Things Network console. Now, previously I've prepared two downlink commands here, and these are in the format that's provided by Netvox. So different manufacturers who might allow downlinks to change keys would have different formats in the downlinks, but this is how Netvox do it, and it's quite simple, as you can probably see. This command here is just 03 followed by a new app UI and then some 0 padding. But anyway, so I'm going to paste that into here. And in this case, it goes on F-port 8, which again is just something that this sensor manufacturer has decided to use F-port 8. So I'm going to queue that downlink. Then I'm just going to press the button on my device. And in fact, it was turned off, so the first thing it's doing is joining. So we're going to have to wait a few seconds for this now to actually join, and then it should get so here's some stuff happening. So there's our downlink being sent just almost straight away. This is the response from the Netvox sensor here to say that it's accepted the new app UI. That's great, that's half the process done. Now I'm going to copy my command to send a new app key to this device, and I'm going to queue that in exactly the same way. Paste it in there, queue that, jump back here so you'll see that that's actually already been sent, because a new uplink has been sent from the device while we were just doing that. So hopefully in a few seconds we should see the confirmation, and there it is, right on cue. So that's it. This sensor is now being provisioned with randomly generated app UI and a randomly generated app key that's only known to me. The device manufacturer doesn't have that logged anywhere, it's just made up by me. Now, if this was real world, I'd turn this device off, which in the case of Netvox just means holding down the button on the side for a short while, and that's turning off now. And then that gets shipped to the customer, who can install it, do whatever they want with it, and it'll just, next time it gets powered on, it will just join using a new app UI and the new app key, which might not necessarily even be on the Things Network. It could be on any network server. Hopefully it's reasonably straightforward for you to see that whilst this was quite a manual process and clearly doesn't scale, you can use the API to the Things Network to automate this process quite simply. So I quite like that method, as I've said, because you can automate it and you can do it on scale, and you can, if you do automate it, then it's really straightforward for your customers. Don't have to think too much about it. But I want to just cover a little bit about key security. I'm not going to go on too long about this because I'm sure you've all read various articles and so on, but I don't think it can really be stressed enough. When you're generating keys, you want to make sure that you are generating random keys. And if you are buying devices with fixed keys, then you really need to be challenging the device manufacturer about what are they actually doing with that information? Are they keeping it securely? Are they distributing it to you and the customers securely? What happens to that data once they've sent it to you? Are they keeping copies of it? If they are, is that secure? If you or anyone else is generating keys, make sure you do them randomly. Don't just do things. I think the worst case scenario that I saw quite recently was a device where that app key was fixed, so it could never be changed, and was actually the device EUI followed by the app EUI, and that was the device key, and that's just horrendous because even on a join request you can see those two bits of information. It's just not secure at all. So maintenance and distribution of your keys. So if you're generating your own keys, if you're sending it out to your customer, do that in a secure fashion. So that means don't email CSV files. You can use, so there's a bit of software that I've used in the past called Private Bin that you can install and run on a web server, and then that allows you to kind of reasonably securely distribute things out to people. So you can upload files to it and they get a single use link that contains a key in the link, and the information it's not even accessible on the server. So even if the server that web application is running on is compromised, people still can't get to it. And in general, I would just try and avoid fixed keys wherever you can, because you just never know what might happen in the future. Even if you're fairly convinced now that the keys are being stored securely, who knows what might happen. And if you can't ever change them, then even if it's not for another 5 years, you might have a problem down the line. So the next thing I'm going to talk about is out-of-band provisioning. So this is essentially where you can set and change the keys on a device, but you're not doing it using LoRaWAN downlinks like we just demonstrated there. We're doing it via some other mechanism. So this requires that the device has some other means of communicating with it. And there's various examples of this that I've seen used. NFC is quite a common one. So typically you'll have an app on a mobile phone, and you'll have your sensors, and whoever's screwing that to the wall or fixing it wherever they're fixing it puts the sensor in place, and then they need to have a smartphone with the manufacturer's app on it, and you use that app to set the device up, set the keys on it, set an app EUI. Sometimes they can use Bluetooth as well, which again, similarly, you need to be physically with the device to actually do that. I've also seen this done by USB as well, so some devices where they have a USB port on them or inside them, and you have to plug a cable in and then reprogram the app EUI and key that way. These are all okay. They all certainly do the job, and I certainly know a lot of people like them because you can just kind of do it as and when you're doing the installation. That's all right. I think if anything, a disadvantage of this is the fact that you have to be there to actually do it. So it doesn't lend itself too well to kind of supplying things in a ready to go state. Which I think, given what's going on in the world today, certainly we're getting a lot of interest from customers who are wanting to find better ways of pre-provisioning things, so that when they get sent to sites, they go in a working state, and all the only person on site needs to do is just power the thing on or put the batteries in it. They don't have to know or care what app EUIs are or anything like that. Certainly when you start scaling really big, especially if you're a small business, you're not going to have teams of people in vans to go around installing these sensors. If you can get them in a state where your customer themselves can just self-install them, then that's great. And perhaps the customers are perfectly happy using a smartphone app to do this over NFC, but I think that's a potential drawback to this method. I think it only scales so far. but it's quite commonly used, and there's certainly no problem with it. And then the last thing I want to talk about is efforts to create standards. So, as an aside to these methods that are being used today, there's at least one or two efforts to actually create a standardized mechanism for doing this. And the most common one that I've come across has been invented by TTI, the Things Industries, which is the commercial arm of the Things Network, alongside Microchip, who are a company who make electronic components. One of the things they make is this Microchip ATEC 608A secure element, which is a little chip that you can put onto a device if you're a manufacturer of a device, and then if you're using the TTI's join server, then it will talk to that join server and actually distribute the keys in a secure fashion there. If you want to know more about this, then I recommend go and have a look at that YouTube video that I've got a link to on there, which is that's a talk by Microchip and Johan from Things Network, actually talking in a lot more detail about how that works. And this is great, but at the minute it's kind of theoretical. If you're actually manufacturing your own devices, then you can go and buy this piece of hardware, the Microchip ATEC component there, and you can put it into your devices. If you're buying off the shelf things, then the chances are they're not going to be able to do this today because they won't have the right hardware in them. So I think this is one to keep an eye on for the future. Which brings me on to kind of the end of my talk now, which is talking about what's going to happen in the future. Well, as I said right at the beginning, my background in IP telecoms, and we solve this problem. We work with various different IP telephone manufacturers and software providers and so on and so on, and we've solved this problem in the voice over IP world. Automatic provisioning of phones in secure fashion is widespread, and we've been doing it for about 15 years. And I keep going on about that because I just don't want people to be scared by it. This isn't a problem that's never happened before. It's not something that's insurmountable. What I think will happen in the future is I think standards will win out. I think something along the lines of the TTI/Microchip method will get widely adopted, or perhaps something else will come along that will get adopted as well. It could well end up being in addition to the LoRaWAN spec. In fact, that standardized provisioning mechanism is done in much the same way that standardized firmware upgrades over the air is now part of the LoRaWAN specification. Provisioning of sensors could well be as well. And that's it. So that's the end of my talk. I hope you've enjoyed it. I hope you've learned something from it. Certainly don't think that mass provisioning of devices is anything to be scared of. If you have any questions about that, or if you want any more information, then feel free to drop me an email to that address on the screen. Otherwise, I hope you enjoy the rest of the Things Network conference.